Hello, Precalculus. This is a special treat for you today. Learning the unit circle, I'll tell you what, it's good at parties, showing this off, attracting a loved one. You see a nice looking girl in the mall and you're like, how do I impress her? Unit circle. Maybe you get asked to go on Jimmy Kimmel Live and it's like, what do we talk about? Unit circle. It's a magnet, people. It's a magnet for intelligence, for good-looking people, people with good attitudes. Your life is going to be forever changed by today's lesson. Let's start with the basics. Now, if these basics you don't know, you can go to my geometry page, section 8.4, and see more examples of this. Because it's something that you are supposed to know from geometry. That's the special right triangles. 45, 45, 90, and 30, 60, 90. In a 30, 60, 90, we often call the side opposite 30 the short leg. Opposite 90 is the hypotenuse, that's the short leg times 2. Opposite 60 is the long leg, that's the short leg times the square root of 3. In a 45, 45, 90, we call each of these short legs, or you could just call it leg. They're both the same length. It's an isosceles triangle. The hypotenuse is the short leg times the square root of 2. In a unit circle, which is what we're studying today, the radius will always be 1. So if you have a radius of 1, and that's twice as big as the short leg, that means the short leg is going to always be a half. If the short leg is a half, the long leg, opposite 60, will always be a half of the square root of 3, which we typically write as the square root of 3 over 2. This is what you must know to be successful at this. Likewise, in a 45, 45, 90, if the radius is 1, and that is square root of 2 bigger than each of the legs, that's going to make this 1 divided by the square root of 2, which we usually write as square root of 2 over 2. In a 45, 45, 90, it's isosceles, so both of the legs are square root of 2 over 2. To sum up, here are the two things you must know in order to fill out a unit circle. You must know that the hypotenuse is 1. You must know that if the hypotenuse is 1 in a 30, 60, 90, opposite 30 is a half, opposite 60 is square root of 3 over 2. You have to know it. In a 45, 45, 90, if the hypotenuse is 1, then each leg is square root of 2 over 2. You have to know it. Once again, if that's new to you, the relationship of a 30, 60, 90, 45, 45, 90, check out my geometry page, notes 8.4. So what does that have to do with a circle? Everything. Check this out. If this is a unit circle, it says that it is. It means the radius is 1. If the radius is 1, that means that if you start at the origin and you go to the right 1, this ordered pair here is going to be 0, it's going to be 1, 0. By the way, don't draw that line that I just drew down there. Just showing it from fastest. If you start at the origin and you go left 1, you've gone left 1, you haven't gone up or down. If you start at the origin and go up 1, you've gone left or right down, you went up 1. If you start at the origin and go down 1, That's 0, -1. Those are the quadrantal ordered pairs, the ordered pairs that fall on the x and y axis. Let's look and figure out what this ordered pair is right here. If this is 30 degrees, which it's showing that it is, and I draw a reference triangle, this is a 30, 60, 90. Let's look at this just a little closer. If the hypotenuse is 1 in this, opposite 30 is half of that, opposite 60 is square root of 3 over 2. That's true in every 30, 60, 90 if the hypotenuse is 1. Therefore, the x value of this ordered pair is square root of 3 over 2. The y value is a half. The coordinates of this point, if we go up 30 degrees on a unit circle, is square root of 3 over 2, 1/2. Let me make sure that I'm writing this clearly. Sometimes my handwriting is not so clear. Let's skip this next point and let's go to this one here. Drop this down. This is saying it's 60 degrees, which makes this 30. This is a unit circle. The radius of this little fella is 1. Opposite 30, the short leg, is half of that. Opposite 60 is the short leg times the square root of 3, so it's square root of 3 over 2. It is not a coincidence that this x value is this y value, and this y value is this x value. Now let's look at the 45, 45, 90. At this 45 degree angle, we make a reference triangle. We have a 45, 45, 90. It's a unit circle. The radius is 1. Opposite the 45s, it's going to be that divided by the square root of 2, which rationalizes to square root of 2 over 2. We've just completed the first quadrant. Once you've completed the first quadrant, well, this is so easy. Check it out. If I take this triangle right here and I reflect it over the y-axis, it's going to give me an identical triangle over here. Only difference is I went left instead of up. So if I take these ordered pairs and I reflect it over the y-axis, my x value changes sign. My y value stays the same. I went left square root of 3 over 2. I went up a half. Let me explain why again. This reference angle is 30. Opposite 30 is going to be a half. Opposite 60 is square root of 3 over 2. The radius is 1. If we apply the same logic to this triangle, I like doing my 30, 60, 90s at once, then my 45s at once. You can do it in any order. It makes this reference angle 60, because 120 plus 60 is 180. This is a half. This is square root of 3 over 2. We went left, so it's negative 1/2. Forgive me for that. And I might have said it wrong on the previous one too. We went left, so it's negative. So this is negative 1/2 square root of 3 over 2. But you don't have to do this work for this triangle, because this ordered pair and this ordered pair, their absolute values are going to be the same. The question is, did you go left or right? Did you go up or down? Logically then, this is going to be negative square root of 2 over 2, positive square root of 2 over 2. Let me color code these for your viewing pleasure. 30, 60, 90s are in blue. 45, 45, 90s are in red. Excuse me. Quadrantals in green. Now, if we take the ordered pairs in quadrant 2 and we reflect them over the x-axis, if you reflect things over the x-axis, the signs of the y values change. If I reflect this point, I'm going to get negative square root of 3 over 2, still going left, negative 1/2 because I went down. If I reflect this point down here, I'm going to get negative 1/2, negative square root of 3 over 2. Left and down, they're both negative. If I reflect this one down here, we're going to get negative square root of 2 over 2, negative square root of 2 over 2. My handwriting is starting to devolve, per usual. Similarly, if I had to either take these points, reflect them over the x-axis, the x values change sign. If I take these points, reflect them over the, if I reflect these over the y-axis, the x values change signs. If I reflect these over the x-axis,